Okey. Hadi arkadaşlar açın ekranlarınızı. Okay. Now look. There is only pressure within this tube. So we have sigma x, sigma y, but tau xy is zero. Okay. Şunu da ekleyeyim, gerek olmamasına rağmen. So tau xy is zero because at this orientation there is no shearing stress. Aysu Kılıç, Erdem, Tolga, Mehmet açın ekranlarınızı. Now, okay, look, we know sigma y prime. You all know that sigma y prime, biraz önce de konuştuk. Sigma y prime is equal to sigma x plus sigma y over 2 minus sigma x minus sigma y over 2 cosine 2 theta minus tau xy sine 2 theta. Now we know these. On the other hand side, when you look at this cylinder as given in the problem, the thickness is 8 millimeters and the diameter is 600 millimeters, right? So R, bakın arkadaşlar, R, which is the inner diameter as defined in our book, is equal to 300 millimeters minus 8 millimeters, and that's equal to 292 millimeters. And thickness is given as 8 millimeters. In our book, this R refers to inner diameter of the pressure vessel. Since outer diameter is 600 millimeters, it means that the outer radius is 300 millimeters. We are subtracting the thickness from that to obtain the R, which is the inner diameter of the pressure vessel actually. So we know everything in this problem except P. Now look, sigma y prime is given as 75 megapascals in the problem. So it is 75 megapascals given for the weld. Sigma x is equal to PR over T. We have just shown that. Sigma y is equal to PR over 2T divided to 2 minus PR over T minus, excuse me, this plus, minus PR over 2T over 2 cosine 60 degrees because beta is given as 30 degrees and plus 0 or minus 0, whatever. Okay. So there is no tau xy in the problem. And now the only, we know R, we know T, we know everything. So the only unknown is the pressure. Solving, okay, pressure is found as 3.29 megapascals from the transformation of the stresses. Arkadaşlar bir kübik eleman üzerinde bu stresleri göstermeyi öğrenin. Çünkü bundan sonra en önemli konumuz zaten bu olacak. Çünkü artık bütün stresleri bulmayı biliyorsunuz. Şimdi gelelim Mohr circle solution'la. Now, Mohr circle is a graphical solution. Actually, there is no need to use it if you understand the stress concept, but it gives you a sense for the analysis. So I'm just drawing a Mohr circle solution to understand it once more. Dediğim gibi yani stresi bilen biri Mohr circle gibi grafiksel yöntemi zaten kullanmaz ama bir öğrencilere rotasyonlar hakkında özellikle bir hissiyat veriyor. O yüzden önemli. Now look, we know sigma 1, which is hoop stress. Okay. Or at least we know that there is a normal stress on that orientation. Then we know, şimdi bakın arkadaşlar, Mohr circle nasıl çiziyorduk? İsterseniz oraya geri döneyim, belki unutmuşsunuzdur. İlk koyacağımız nokta neydi? Hatırlayan var mı içinizde? The first point is the point X. So, bakın şu elemanı çiziyorum arkadaşlar. On this element, the first point is X tau XY. So, X tau XY is here because tau XY is 0. So, this is X, which is sigma X minus tau XY. This point is Y. Okay, şöyle uzakta göstereyim. This point is Y. Y is sigma Y, tau XY. But we know that tau XY are 0. And sigma X is equal to sigma 1. So this is sigma 1 and this is sigma 2. Therefore, here is the Mohr circle for this problem. Okay. So this point is X. This point is showing the surface X. This point is showing the surface whose normal is Y. In this problem, X and sigma 1, Y or sigma Y and sigma 2 are coinciding because there are no shearing stresses. Look. Now, buraya bakın arkadaşlar. Look, concentrate on the surface. If I rotate the surface as much as 30 degrees in the counterclockwise direction, I reach sigma Y prime. Oldu mu? Bakın şu şekle bakın. At the same point at A, if I rotate this cubical element as much as 30 degrees in the counterclockwise direction, sigma Y becomes sigma Y prime. Which means that since this is point Y here, if I rotate this element as much as 2 times beta 60 degrees, then I reached this point. Okay, şöyle yapalım. This is center. Takip ediyorsunuz değil mi? Bir daha çizeceğim. Okay, then niye mavi alamadım anlayamadım. Okay, now look. When I rotate this element as much as 60 degrees, 2 times 30 here, now my Y, which were here, now at this point, this is Y prime and this is X prime. Y prime is now on the Mohr circle, this surface. Anlaşıldı değil mi arkadaşlar? Artık burası. Okay, I know that this is sigma average, this point. So what is sigma Y prime? From geometry, look at the geometry. Sigma Y prime is equal to sigma average minus radius of the curvature times cosine 60 degrees. What is sigma average? It is sigma X plus sigma Y over 2. Bakın şurası sigma average. İsterseniz şurayı bir kez daha yazayım. This point is sigma average. Eğer takip ettiyseniz formülasyonu daha önce. What is R? R is the radius of the circle. Remember, R is this. Sigma X minus sigma Y over 2 square. Minus plus tau XY square. This is the radius of the circle. So remember, look at your notes. This is sigma average. This is R times cosine 60 degrees. Now look, you know sigma X, sigma Y, everything. You know sigma Y prime, which is given as 75 megapascals. Solving, artık tek tek yazmıyorum R'ları, P'leri falan. P is equal to 3.29 megapascals. Çünkü sigma X, sigma Y hepsini ardından biliyorsunuz. Yukarıda yazdım. Bir daha yazmıyorum. Vakit kaybetmeyelim. Okay. Bakın arkadaşlar şunu yaptık. Lütfen buraya bir kez daha bakın. Now, this point shows sigma Y prime. It is sigma average This is radius sigma average minus r times cosine theta, just from geometry. Okay? Just from geometry. Geometriden buluyorsunuz zaten. Ama biz tabii geometriden ölçecek halimiz yok, formüllerle buluyoruz. Normalde grafiksel bir yöntem. Buraya kadar herhangi bir sorunuz var mı? Pressure versus law'la ilgili. Şimdi bu chapter'ın son kısmını şöyle gideceğim. Yazarak gitmeyeceğim hızlı olsun diye. Arkadaşlar anlamadığınız bir yer var mı? Lütfen sorun geçmeden. Takıldığınız, aklınıza yatmayan, tereddüt ettiğiniz.
Hocam burada arı hesaplarken direkt sigma 1 ile sigma 2'nin farkını alıp 2'ye bölsek neden olmuyor?
Arı yarıçapı bu dairenin. Tamam. Onun formülü bu.
İşte yarıçapı bulmak için mesela sigma 1 ile sigma 2 direkt yatay eksende oldukları için aralarındaki farkın yarısı direkt arı olmaz mı?
Zaten dediğin gibi oluyor. Çünkü burada tau xy'nin değeri ne? Tau xy'nin?
Yani 0.
0. Ama bu problemin özel bir problem. Burada shear stres olmadığı için böyle. Şimdi genelde bunu böyle...
Ha, bu genel tanım sadece.
Bu genel equation. Yani bu da shear olsaydı eğer, bu problemde shear yok. Bakın yukarı çıkayım. Gördüğün gibi şurada shear yok. Ama tabii ki formülü bunsuz yazamam. Yani genel formülü biz yazalım. Sen shear'ın yerine 0'ı koy. Oldu mu?
Tamamdır hocam. Teşekkür ederim.
Yani problemde bu bir basınç problemi olmasaydı, elemanınız bu yönde olmasaydı, mesela şöyle rotasyon olsaydı shear olacaktı. O zaman bu denklemde tau xy non-zero gelecekti. Ben genel formülü yazıyorum ama dediğin gibi burada tau xy zaten 0 ve dediğin yere geliyor zaten. Oldu mu? Başka soru? Zaten geometriden de görüyorsunuz. Bu problemde arkadaşların söylediği doğru esasında ama genel yazalım equation'ı ki diğer problemlerde bir sorun yaratmasın. Peki. Şimdi gelelim şeye. Plane strain'e. Buradan kopyalayarak gideceğim şimdi. Şimdi arkadaşlar esasında ben şöyle yapayım. PowerPoint'e geçeyim burada. Tamam. PowerPoint'ten devam edeceğim bundan sonrasını. Kitapta aynen var. Şunun için sonunda niye oradan devam ettiğimizi söyleyeceğim. Plane strain. Okay. Now, when we say plane strain, this time, look. Önce şuraya bir kopyalayayım şunu. Now, in the plane strain, consider a case. Look, now, plane strain is different than the plane stress. Consider a case when the dimension of the, where the dimension of the body in one direction, şunu ver yapalım, daha doğru olacak. Where the dimension of the body in one direction, say Z, okay, is very large, infinitely long, or restrained from expanding and contracting laterally in that direction. Further, all the deformations of the material take place in parallel planes and are same in each of those planes. This state is called plane strain. Then, in general, we have the following stress state. Şimdi belki çizgi daha net olacak. Okay, the stress state is this. This time, now remember, in the plane stress, the stresses in Z direction were zero. But in the plane strain, belki şu ikisinin yerini değiştirsem daha doğru olacak. In the plane strain, the strain in one direction, maybe in Z direction are zero. Bir saniye arkadaşlar. Şöyle olacak. Şöyle düzelteyim. Şimdi stresi de yazayım. Şuraya paste edeyim. Bu böyle kalsın. Şunu da elle yazacağım şu anda. Sonra buraya geri döneceğim. Bir şekli gösterip ondan sonra döneyim ki biraz bu anlattıklarım anlaşılsın. Bir de şunu kopyalayayım. Copy. Paste. Bir de bir şekil kopyalayalım şuradan. Copy. Bakın. Şu şekle iyi bakın arkadaşlar lütfen. Önce bu şekil üzerinde konuşup biraz önce söylediklerime tekrar geri döneceğim. Now, please look at this figure. This is an example of the plane stress problem. There are two fixed supports, and there is a plate within these fixed supports. Look, there is a plate here. Now, if you look at this plate, the loading on this plate is same on all planes parallel to XY planes. Is this clear? The loading on this plate is same on all the planes parallel to XZ plane. Further, because of these fixed supports, there is no way for this plane to expand or contract in Z direction. This means that epsilon Z is 0. Okay, epsilon Z is 0. Because of loading, gamma XZ is 0. Because of loading, gamma YZ is 0. This is a plane strain condition. Remember, in the plane stress, stresses were 0. In the plane strain, strains in one direction are assumed as 0. Okay, now turning back. If dimensions of the body in one direction, say Z is very large, still this situation holds. Or if you restrict the element to expand or contract in one direction, then the strains in that direction are 0. So as a result, the strains in one direction, say in Z direction, epsilon Z, what shear stress in YZ, the other shear strain, the strain in Z direction, epsilon Z, shear strain YZ, and if shear strain XZ are all assumed as 0, whereas epsilon X, epsilon Y, gamma XY are non-zero, this is called as plane strain. As a result of this, sigma X, sigma Y, tau XY are non-zero. However, because of Poisson's ratio, now sigma Z is non-zero. So, plane strain occurs in a plate, for example, restrained from both ends, okay, by rigid or fixed supports. Burası anlaşıldı mı arkadaşlar? So therefore, this is an example of plane strain. Now, since these stresses are 0, obviously, let me write once more, we expect epsilon X to be non-zero, we expect epsilon Y to be non-zero, we expect gamma Y X or XY, let us write the correct order, XY is non-zero. So the 6 components of stress, but the stress is in one direction. Here Z, it could be Y or whatever, are 0. As a result of this, the sigma X is non-zero, sigma Y is non-zero, sigma or tau XY is non-zero, right? Tau XY is non-zero, but this time sigma Z is non-zero because of Poisson's ratio. However, tau XZ is 0, tau YZ is 0. This is a plane strain condition. Plane strain means that the strain in one direction can be assumed as 0. Then your three-dimensional problem turns into plane strain condition. Now here, let me repeat once more plane stress. In the plane stress, the basic assumption is this. Sigma Z is 0, tau XZ is 0, tau yz is 0. So our assumption starts with stress. And sigma x is non-zero, sigma y is non-zero, tau xy is non-zero. This is the assumption. Here, this is the assumption. Okay. Oldu mu arkadaşlar?
Hocam plane strain'de tau xy non-zero değil mi?
Bir saniye. Tau
xy.
tau xy onu yazdım non-zero. Evet. Şunu diyorsun değil mi?
Evet, şu sağ en altta yazan. Evet.
Evet, evet, haklısın. Şu non-zero, şunu diyorsan. Tamam. Yani sonuç olarak plane stress'te bir yöndeki stresleri, plane strain'de bir yöndeki strain'leri sıfır kabul edebiliyorsunuz. Shortly, in plane stress, in one direction all stress can be assumed as zero. In plane strain, the strains in one direction are assumed zero. In both cases, because of Poisson's ratio, in the plane stress, the strain in the z direction. In plane strain, the stress in the z direction are non-zero. Okay, this is the result. Oldu mu? Peki. Şimdi the transformation equations of plane strain. Let me tell you about that. The transformation equations of the plane strain are the same with the stress. Hiç çıkarmayacağım. Bakın arkadaşlar. These equations are very similar to the equations that we obtained for plane strain. The only difference is this, because both of our tensors, all tensors are determined in the same manner. So, from the stress transformation equations, now let me add this. From the stress transformation equations, okay, from the stress transformation equations, which we discussed in detail for plane stress, okay, replacing sigma by epsilon, tau by gamma over 2, you obtain equations. You can obtain the equations for plane strain. Okay, so use equations for plane stress, change these sigma with epsilon, tau with gamma over 2, then you obtain the equations for plane strain. Okay. Now, what about Mohr circle for plane strain? Okay, the logic is exactly the same. The Mohr circle for plane strain is obtained in a similar way. Now, this axis is previously sigma, now it is gamma. This axis was previously tau, but it is replaced with 1 over gamma, as I just mentioned. All are the same then. Okay, you can use all these equations as you use in plane stress. So all the equations that you have learned in plane stress can be converted to plane strain just by replacing sigma with epsilon, tau with gamma over 2 gamma. What you get is the same. Any question? Uzun üzerinden gitmeye herhalde gerek yok. And for example, this is the three-dimensional circle or plane strain by considering the other two, because if you are using plane strain, there is always a third strain which is zero, as we discussed previously, and that is zero. Okay. What else? For example, okay, copy. One other example is this, Mohr circle for plane strain. One principle is maximum, the other principle stress is minimum, right? And şunu gösterdim, hatırlayamadım, bir daha kopyalayayım. Copy. Paste. Aynısı olduğu için üzerinden gitmeye gerek yok. Bakın arkadaşlar, şu iki mor circle'a bakın. In one, the maximum on the right, the maximum and minimum in plane principal strains are both positive. Okay, so at A, we have here epsilon max in plane. At B, we have epsilon min, okay, in plane. This plane strain. Here, this is epsilon max, and B is epsilon min. So as a result, this is the first principal strain, this is the second principal strain, but we have a third one which is zero. On the other hand side, here, this is the first principal strain. Since the second one is zero here, this is equal to third principal strain. Now, look, the tau max here, on the left, this is equal to 1/2 tau max in plane. Why? Because one principal stress is positive, the other principal stress, which we found, is negative. But in the plane, if both are positive in plane strains, then this gamma max is greater than 1/2 gamma max in plane. Okay, so remember, at the end of the solution, the strains that we found by plane strain is this and this, or this and this. Third one is always zero. It changes the value of the maximum tau max on the section. Buraya kadar bir soru var mı? Gördüğünüz gibi stresteki bütün denklemleri burada aynen kullanabilirsiniz. Herhangi bir sorunuz var mı arkadaşlar? Son kez tekrarlayayım. All the equations that we obtained are same for strain. The only difference is that you can replace sigma with epsilon or epsilon with sigma. However, for tau, use 1/2 gamma. Why? Because stress tensor is this, not gamma xy. This is the engineering quantity, this is the continuum quantity. That's why the relation between these is the following. Gamma xy is equal to 2 times epsilon y. Because of this, by using these two, you can obtain all these equations. If you know the Mohr circle for stress, you can draw the Mohr circle for strain in the same manner, keeping this in mind. Bu kadar yeter. Çünkü bu derste bunu anlatmaktan ziyade sadece bahsetmeyi amaçlıyoruz. O yüzden hani sadece bilginiz olsun diye açıkçası bundan bahsettim. Şimdi bir problem daha çözeceğim. Ama tekrar soruyorum. Bunlarla ilgili aklınıza takılan bir şey varsa hemen şimdi cevaplayın. Şimdi arkadaşlar, bu plane strain kısmını kitaptan lütfen okuyun. Yani genel bir bilgi olsun diye. Şimdi bakın. Şu probleme bakın lütfen. Artık bu tip problemleri çözebilmeniz lazım. Yani bu dersle birlikte. Look, a steel pipe of 300 millimeter outer diameter is fabricated from 6 mm thick plate by welding along a helix. Bir önceki probleme çok benzer ama ne farkı var? There is an axial force and there is a torque on the system in addition. And the helix angle is 22.5 degrees. There is a force of 160 kilonewtons from top. There is a torque of 800 Newton meters, as you see on the figure. Now, we are looking for sigma and tau in the directions respectively, normal and tangential to the weld. The problem says this. If I use a cubical element here, Okay, an inclined cubical element like that, an inclined one, I am looking for sigma and tau on this element. Okay, this is the question. Now, let me remind you once more. All the equations that we obtained up to now, axial loading, bending MCORI, TCOJ, torque, whatever, are for the planes which are perpendicular to the axis of the cylinder. They are valid for such a plane which is perpendicular to the axis. Okay, all the equations. So they cannot be used for these inclined surfaces. Therefore, we need transformation equations. But let us start with those equations. Now, just take a section from this pressurized vessel. Now, what we have is this. We have such a section. Look, we have such a section. Let me read it over once more. Now, this is a pressurized vessel. Okay. Say that this is a good figure. And this is a part of the pressurized vessel. Here is the weld. Now, this point is on the surface. And say this point is A. By the way, we know that this angle of this weld from the horizontal, just a minute, please. Okay, this is the tangent. And there is an angle here. And this angle is 22.5 degrees. Is this clear? Now, on this cross section, say that this is centroid of the cross section, we have two laws. One of them is the axial load P. Okay, look, as given in the problem, we have an axial load P acting in the middle. And also, we have a torque, vectorially this one. What else? Is there pressure within this member? No, there is no pressure. Basınç yok değil mi içinde? Yok. Okay. Now look. If I take a cubical element at A, let's attach a coordinate system to the problem first of all. Now I am saying that I am using such a coordinate axis. This is X, this is Y, and this is Z. Okay. Ya da isterseniz buraya koordinat eksenlerini hiç koymayın. Karıştırıcı olacak şimdi. Arkadaşlar şöyle yapayım. Koordinat eksenlerini size daha iyi göstermek için önce koordinat eksenlerini koyayım. Şey olsun. Öbür türlü de anlamsız olacak. Şimdi kafanız karışabilir. Şu noktayı ondan sonra koyayım. X, Y, Z, right? Now, I am changing the location of the point and putting on the Z-axis here. Okay? This is point A. Now, this is the weld. And we know that this weld is making 22.5 degrees with the x-axis. Now, keeping this orientation, I am drawing a cubical element. Look, this is the cubical element at A. At A, because I have to show the stress state clearly on a cubical element. This is my cubical element. İyi takip edin lütfen. At A. And I am referring to the same coordinate system now. This is the x-axis. Okay? This is the y-axis. And this is the z-axis. Şimdi Bengüsü Kaya yukarıdaki kırmızı yüklere bakarak bana stresleri söyleyebilir misin? Mesela P'den başlayalım. P ne yaratır? What is the stress created by P?
Normal stress.
Normal stress. Is it compressive or tensile?
Compressive.
Okay. As your friend said, because of P, we have such a normal stress. It is sigma, yes, what? Subscript is?
Y.
Sigma ne olacak? Anlayamadım.
Y.
Y. Efendim? Y mi dedin?
Evet.
Sigma Y, okay. This is sigma Y. So your friend said that there is a compressive stress sigma Y. And peki değeri söyler misin bana Bengisu? Sigma Y is equal to minus P over A. Doğru mu?
Yes.
Yes. P is equal to, if you look at the problem, 160,000 newtons. What about area? It is pi times, bir de alanı söylersen bana memnun olacağım. Bir boru var değil mi?
150 square.
Peki bir saniye lütfen. Kalemi alamadım bir türlü çünkü. Okay. So it is pi times, you said that 150 millimeters square, right? But this is the outer diameter. The
Minus
minus, yes.
144.
4 millimeters square and multiply this pi. Is it plus or minus? Minus. So sigma y is equal to, let me write it here, minus 28.87 megapascals. Okay, thank you. Now, Kerem Gül. Kerem, there is a torque, as you see on the cross section, right? This torque will create shearing stresses. We know it, right? Okay. Could you tell me the direction of the shearing stress on the cubical element? Hoparlörünü aç istersen önce. Heh. Hangi yüzdedir? Önce onu söyle bana. Shear stress. Tahminin nedir? Şu yüzde olur değil mi? Üstteki yüzde. Doğru mu?
Hı hı.
Peki. Sağ mı olur, sola mı olur? Şuna baktığın zaman aynı yönde olması gerektiğine göre sağ mı olur, sola mı olur?
To the right.
To the right, yes. So this on this plane, on this surface, we have such a shearing stress. Okay. This torque will create such a shearing stress. And if I have one here, there must be one on the surface, one on the surface, and one on the surface, which is tau x, yes, y.
XY.
Okay. Now I am looking for its equation. So this shearing stress tau xy is due to torque. Okay. And torque is equal to 800 newtons meter. So tell me the equation of this shearing stress, because you know torsion. So that is tau xy, which is equal to, yes, t times. Hatırlıyor musun?
I don't remember.
Bu equation'ları ezbere bileceksiniz arkadaşlar. 4 tane 5 tane equation var. T times
TC
okay, dediğin gibi yazalım peki. T C over
J.
J, good. Torque is equal to 800,000 newtons millimeter. Okay. C is the radius, which is equal to, şurada görüyorsun zaten, bir üstteki denklemde 150 milimetre değil mi?
150.
Outer radius, yes. J is very obvious. If we use the diameter pi over 2, so radius, 150 millimeters to power 4 minus 144 millimeters to power 4. Now, if you solve this, what you get is the following. On this cubical element, the shearing stress due to torsion is equal to, okay, let me write the numerical value to here, 1 megapascals, very small. Okay. Plus or minus, it is positive.
Plus.
Positive X, positive Y. Okay, thank you. Oldu mu arkadaşlar? Şimdi herhangi bir tereddüt ettiğiniz konu var mı buraya kadar? Aklınıza takılan yönlerle ilgili falan şunla bunlar. Evet. Evet. Hayır olmazdı. Sadece axial loading o. Bu benim aldığım bir kesit. Böyle ortada durmuyor tabii. Yukarıdaki plakaya basıyor. Burası benim gösterdiğim herhangi bir kesit. Şöyle bir kesit aldım burada. Tabii ki bu kesitin sentroidinde ama tamam mı? Yukarıdaki plakaya basıyor. Bütün çepere. Hiçbir şey yaratmaz bu. Her tarafta aynı miktarda basar. Bir basınç yaratır yani bir sonuçta. O da sigma y'dir zaten. Oldu mu? Peki. Şimdi bunları biliyoruz. Kübik elemandaki stresleri böyle koymayı çok iyi bileceksiniz arkadaşlar. Bunu unutmayın. Okay. Soru neydi ona bakalım. Okay, we are looking for sigma and tau on the directions normal and tangential to the weld. Now we are looking for this. This cubical element is a must because all the equations are derived for that. However, the question is asking a cubical element in 2 dimensions. Okay, by the way, is this plane stress or plane strain? Who is going to tell me? This is plane stress. The stress is in one direction, R0, okay, in Z direction. So if I rotate this element, what I get is this, right? Now this is my new orientation, parallel to the weld. Kaynağı paralel, bakın arkadaşlar, yukarıdaki kaynağı, okay? So, tabii açılar rastgele çiziyorum, ben dikkat etmeden. This is the x-axis, this is the y-axis, which I know the stresses. Now we rotated it by an angle theta, which is equal to the angle of the helix. Now look at the problem. The helix angle, look at here, is equal to 22.5 degrees. So now this angle is equal to 22.5 degrees. When we rotate the element like that, it's very clear that we have a number of stress on it. Now, we have a normal stress in y direction. Okay. Bunların yönlerini çözünce zaten çıkacak. Ben rastgele koyuyorum. Biraz da bilerek koyuyorum gerçi ama neyse. We have sigma x prime, sigma x prime, and I also shearing stress on it. Say this one, this one, this one, and this one. Tau, x prime, y prime. Zeynep Kaya, buradaki stresleri, prime'ları bizim formüllerden bulabilir miydim? TC over J'den, MC over I'den, her neyse yani. Evet mi, hayır mı? İlk önce.
Hayır sanırım.
Hayır. Niye? Çünkü bu eleman longitudinal membrane eksenine dik veya paralel kesilmemiş. Değil mi?
Evet.
O yüzden bununla başlıyoruz buradakiyle. Umut Berk ekranın karardı. Kamera. Umut Berk Karakaya. Heh. Tamam mı arkadaşlar? Bu denklemler ancak bu oryantasyondaki bir eleman için geçerli. Peki böyle eğdiğimiz zaman ne yapacağız o zaman? Nasıl çözeceğiz problemi? Ne kullanacağız? Genel sordum. Kim cevaplarsa. What should we do for sigma x, sigma y and tau x, y prime? Or circle, yes, a correct answer. What else?
Transformation equations.
Transformation equations is the best way to use, in fact, after learning everything. If it is not as you specifically Mohr circle or equilibrium equations, I always prefer, in mechanics, we always prefer transformation equations, simplest. Why? Because normal to the weld, I am looking sigma y prime. What is sigma y prime? Sigma y prime is equal to, en kolay bu esasında, sigma x plus sigma y over 2 minus sigma x minus sigma y over 2 cosine 2 theta minus tau xy sine 2 theta. Now in this problem, okay, in this problem, her ne kadar yukarıda kaldıysa da ben nümerik değerlerini yazayım. Sigma x var mı bu problemde? Bakın arkadaşlar. Is there a sigma x? There is no sigma x. Okay. So we have all the numerical values. 0 plus minus 28.87 megapascals over 2 minus 0 minus 28.87 megapascals because it is compressive over 2 times cosine 2 times theta, okay. Okay. Just a minute. Cosine 2 times 22.5 degrees. 22,5 değil mi? Evet. What else? Minus tau xy from torsion, which is 1 megapascals, very small value, times sine 2 times 22.5 degrees. If you solve this, you will see that sigma y prime is equal to minus 25.35 megapascals. So the stress on the weld in the normal direction is this, compressive 25.35. What else? On the weld, now look, weld corresponds to this phase. X'e karşılık gelseydi ona bakacaktık. Weld corresponds to sigma y prime. We need tau x prime y prime. Again, the transformation equations for shearing stress is minus sigma x minus sigma y over 2. Bu denklemleri zaten sınavda veririz size sorarsak. Plus tau xy cosine 2 theta. Then, okay, this is equal to minus 0 minus, şu minus unutmayın bakın, compressive doğru taşıyın. Şekilde bu minus'ı göstermek zorunda değilsiniz. You don't need to show on the figure. But in the equation you should. Yeah, write it. Over 2 times sine 2 times 22.5 degrees. I'm writing explicit 2 here. Plus tau xy, which is 1 megapascals, as we found from torsion, times cosine 2 times 22.5 degrees. If you do that, you will see that the shearing stress on the weld is equal to minus 9.5 megapascals. Of course, the directions of the stresses on the cubical element should be in accordance with the stresses. I know them and put the correct values, but if you don't, turn back to the figure and correct them. Sigma y is compressive and shearing stress is negative, so they should be in accordance with your results. Burada sigma x'i de bulsaydınız transformation equation'da, her ne kadar sorulmamışsa da ben yazayım. Also, sigma x prime is equal to minus 3.521 megapascals. So it is also compressive, as I already shown. So if we are at the beginning, just put them arbitrarily, but then correct after solving the equations or draw the cubical element later. Buraya kadar herhangi bir sorunuz yoksa burada duracağım. Bu soruya dikkatle bakın. Artık bundan sonra bu tip sorulara geçiyoruz. Combined loading sorularına. Bu chapter'la ilgili çözeceğim son soruydu zaten bu. Şeye başlayacağım çarşamba, perşembe günü de diğer chapter'a. Bunu Morse-Circle'la belki bir çözelim. Ona fazla şeyle karar veririz. Sorunuz var mı arkadaşlar? Peki. Yoksa
Hocam,
evet.
son kısmı tekrar gösterebilir misiniz? Not alamadım da.
Şu shear kısmını, evet. Bildiğiniz transformasyon equation'larını doğrudan.
Teşekkür ederim.
Peki. Arkadaşlar sorunuz yoksa burada kapatıyorum.